Behind Ferrari's most iconic solution, there are stories of physics, design, and technological evolution. Welcome to Ferrari Unpacked, the series that makes innovation simple. Episode 1, a matter of balance, center of gravity and its significance. One of the key principles of design is that form follows function, meaning design should be guided by practicality, not appearance. Something that's also true in nature. A flexible spine delivers the cheetah's speed, and the tail ensures balance during quick turns. In a similar way, skiers compress into the turn, lowering their hips to almost touch the snow. Sound familiar? That's right. When it comes to sports cars, having a low center of gravity is key to ensuring grip, responsiveness, and speed. But where is a car's center of gravity? Let's go back to basics. The definition is simple. The center of gravity is the theoretical point where an object's entire weight is concentrated, relative to which the masses of all the components are in equilibrium. If we take a stack of plates, it's easy to identify the center of gravity. But for a car, it's a bit more complex. In fact, unlike a stack of plates, a car moves. And the motion of a body comes from the interaction of the forces acting on it. Forces, plural, because there are several in play. We've got gravity, where the force is mass times gravitational acceleration. Then there's traction force, generated by the engine and transmitted to the drive wheels. This propels the vehicle forward. This is countered by braking force, which comes from the friction between the tires and the ground, as well as by the air's resistance to forward motion. Then there's the law of inertia, the tendency of a body to continue doing what it is already doing. If it is stationary, it will remain so. If it is moving, it will keep moving in a straight line at a constant speed, unless a net force stops it or changes its direction. Because the forces act at different points and in opposite directions, the car is subject to what is known as a pitching moment. The lower the center of gravity, the less pitching there will be. But what happens when we turn? In this case, the most significant factor is inertia, which tries to keep the car going straight, pushing it toward the outside of the turn. This results in a centrifugal force which acts on the center of gravity itself. At the same time, the tires exert an opposite centripetal force generated by their grip on the road. Because of the inertia, the vehicle tends to tilt, transferring more weight to the outer wheels and less on the inner ones. This load imbalance creates what's known as a roll moment. In this case, too, a low center of gravity ensures less roll. So the center of gravity should be as low as possible, right? Yes and no. As we said before, design follows function. Right from the outset, Ferrari aimed to combine speed, power, and control. But not all Ferraris are the same. That's why the center of gravity is never in the same position. The first thing to consider in the design stage is the position of the engine and gearbox, key components in weight distribution. Let's take a look at how their position in the car has changed over time. One Ferrari model was especially personal and technically important to Enzo Ferrari: the Dino. In 1955, Alfredo Ferrari, known as Dino, suggested his father that they develop a rear-mounted V6 engine for Formula 2 racing cars. This idea made it to the road in the Dino model. the first mass-produced road car with mid-rear engine. Thanks to its compact size, the V6 engine could be mounted in a transverse position behind the seats, leaving room for a small boot and a relatively spacious interior. This choice was by no means obvious. At the time, it was standard practice in the Gran Turismo market to position the engines at the front for space and comfort. So why a mid-rear position? Cars with a front engine are less responsive when entering a curve because they naturally tend to have more understeer, pushing the front end wide in a turn. Positioning the engine in a mid-rear layout improves agility when entering a curve. It's just like figure skaters. To spin faster, they pull in their arms and legs. The closer a car's mass is to its center of gravity, the lower its moment of inertia and the quicker it responds. A great example of this approach is the 499P, whose V6 is in a mid-rear position, supplemented by an electric motor on the front axle to provide all-wheel drive. Knowledge gained from the 499P was then fed into the design of Ferrari's new road cars. The F80, which brings this approach to the road, has a significantly lower center of gravity thanks to a clever engine layout. So is that the end of front-mounted engines? Not exactly. Placing the engine at the front is still a solution if you want more space inside and a larger boot. However, there is a solution for sport cars that combines space and agility. A transaxle layout. It rebalances the weight by moving the gearbox to the rear axle, creating a strategic counterweight to the engine. The Ferrari 12 Cilindri is the latest model to benefit from this choice, with a weight distribution of 48.4% at the front and 51.6% at the rear. Every sports car is a balancing act, where every element contributes to the overall harmony, creating a car that defies the laws of physics. But we'll talk more about that in the next episode, dedicated to aerodynamics. Whether sports cars or Gran Turismo models, Ferraris are pioneers of cutting-edge technologies and solutions, thanks to the technological expertise developed over more than 70 years in the world of racing.